Hello everyone. So this is our next topic in the unit solutions, ideal and non-ideal solutions. And our next topic will be some very important definitions throughout the chapter. So now, what are ideal solutions? The solutions which obeys Rolle's law are called ideal solutions, and which do not obey Rolle's law are called non-ideal solutions. In case of ideal solutions, the vapor pressure, partial vapor pressure of any component, solute or solvent, वो इक्वल होता है मोल फ्रैक्शन ऑफ दैट कंपोनेंट एंड मल्टीप्लाइड बाय इट्स वेपर प्रेशर इन प्योर स्टेट. It means P is directly proportional to X. So if we plot the graph according to Rolle's law for vapor pressure of A, vapor pressure of B, solvent, solute, with respect to mole fraction, then this comes like this. How? Mole fraction of A is equal to 1 and mole fraction of A is equal to 0 means जब A के अंदर हम B को मिक्स करना शुरू करते हैं तो जो B का मोल फ्रैक्शन है वो 0 से इंक्रीज करते हुए ऑलमोस्ट प्योर हो जाने के बाद 1 हो जाता है एंड दैट ऑफ A decreases from 1 to 0. And the partial pressure is directly proportional to mole fraction. So mole fraction of B increase and its partial pressure also increases, and mole fraction of A decreases, so its partial vapor pressure also decreases. And this is the sum of A and B, means the vapor pressure of solution at a particular concentration. So this is the graph for an ideal solution. In case of ideal solutions, the structures of solute and solvent are very similar. For example, benzene and toluene. This is benzene, this one is toluene. तो structures जो हैं वो काफी ज़्यादा similar हैं. And due to which the attractions between A and B, means solute और solvent में जो attractions हैं are same as of pure AA and pure BB. जैसे फोर्स ऑफ अट्रैक्शन बेंजीन के साथ है और टोल्यूइन के साथ है, तो मिक्सिंग के बाद भी फोर्स ऑफ अट्रैक्शन जो है रिमेन्स सेम. एंड सो द डेल्टा H मिक्सिंग एंड डेल्टा V मिक्सिंग रिमेन्स 0. मींस मिक्सिंग के बाद जो हीट है neither evolved and nor absorbed because no effect on the forces of attractions, and the volumes comes to be same as expected, so no change in the volume. Delta V is equal to 0. But if we talk about non-ideal solutions where the Pi is not equal to Xi into P naught I, means the vapor pressure of a component is not directly proportional to mole fraction. Either it is more than this or less than this. So the graph comes like this. Means expected graph है किस तरह से आएगा, डैश्ड. बट ड्यू टू दिस फैक्टर जो ग्राफ है इट कम्स मोर देन नॉर्मल. हाउ? एंड इन केस ऑफ नेगेटिव इट कम्स टू बी लेस देन नॉर्मल वेपर प्रेशर. हाउ? एक्सप्लेनेशन. द एग्जांपल इज इथेनॉल एंड साइक्लोहेक्सेन फॉर पॉजिटिव डेविएशंस and acetone and chloroform for negative deviations. The structure of solute and solvent are quite different. Solute solvent के structure ऐसे नहीं है जैसे ideal solutions में है similar. वहां पर non ideal solutions में दोनों में positive और negative derivative solutions के अंदर different होते हैं, जैसे कि आप देख सकते हैं इथेनॉल एंड साइक्लोहेक्सेन, एसीटोन एंड क्लोरोफॉर्म. और उसकी वजह से जो attractions हैं between A and B are very different than the attractions between pure AA and pure BB. In positively derivative solutions, A और B में attractive force mixing के बाद weak हो जाते हैं, और negatively derivative में mixing के बाद force of attraction A और B के अंदर stronger हो जाते हैं than earlier. How? When we mix cyclohexane in ethanol, then the hydrogen bond of ethanol is broken by cyclohexane, so bond becomes weaker. Heat is absorbed to break the bonds, means delta H positive. and volume expands due to weakening of the bonds. So delta V mixing comes to be positive, means more than the expected volume. Means after mixing, heat is absorbed and volume increases. But in negatively diluted solutions, for example acetone and chloroform, they form hydrogen bond, and this is stronger than the earlier bonds of pure state. And due to this, the attractions increases, so heat is released, means delta H negative. And when attractions increases, molecules comes close, then the volume decreases. So volume comes to be delta V mixing negative. And in graph, when forces are weak, then vapor pressure will be more, and when forces are stronger, then vapor pressure will be less than normal vapor pressure. So graph comes to be in positive form, more than this normal graph, and here vapor pressure comes to be less than normal graph due to more attractions. So like this, there are so many other solutions of positive and negative types. So we can say in non-ideal solutions, delta H and delta V of mixing is not equal to 0, means more than 0 or less than 0, positive or negative correspondingly. There is one more topic, azeotrophs. There is a particular concentration, एक point है जहाँ पे जो वेपर प्रेशर है वो है मैक्सिमम, तो इस पॉइंट पे जो बॉइलिंग पॉइंट है मिक्सचर का वो होता है मिनिमम, और इसे बोलते हैं मिनिमम बॉइलिंग एजियोट्रोप्स। और नेगेटिवली डाइल्यूटेड सॉल्यूशंस में एक पॉइंट है जहां पे वेपर प्रेशर है मिनिमम, तो बॉइलिंग पॉइंट है मैक्सिमम, उसे बोलते हैं मैक्सिमम बॉइलिंग एजियोट्रोप्स। एजियोट्रोप्स आर दोज मिक्सचर्स which behaves like pure substances and have a constant boiling point, and they do not behave like normal mixtures which are having no fixed boiling point. एजियोट्रोप से 2016 में क्वेश्चन आया था, what type of azeotrophs are formed by negatively diluted solutions? So these are minimum vapor pressure and maximum boiling. And what type of azeotrophs are formed by positively diluted solutions? So vapor pressure is maximum and azeotrophs are minimum boiling azeotrophs. For example, 95% aqueous ethanol वो एक मिनिमम बॉइलिंग एजियोट्रोप है क्योंकि ये एक पॉजिटिवली डाइल्यूटेड सॉल्यूशन है, एंड 68% नाइट्रिक एसिड इज ए मैक्सिमम बॉइलिंग एजियोट्रोप क्योंकि एक्वस स्टेट में HNO3 दिस इज ए नेगेटिवली डाइल्यूटेड सॉल्यूशन. So azeotrope is also another very important topic, and this one is completed about ideal and non-ideal solutions. तो इसमें आप इसको अच्छे से लर्न करें, रिवाइज करें, और थ्योरेटिकली जो हमारा क्वेश्चंस हैं, जो पोर्शन है वो यहाँ से पूछे जाते हैं. So these are the properties of ideal solution, these are non-ideal solution properties, and these are two types of the non-ideal solutions, positively diluted and negatively diluted solutions. So in next topic we will discuss about some important definitions which also are very important for the exam. और इसमें से 2 marks का जो क्वेश्चन हमारा बचता है कोलिगेटिव प्रॉपर्टी से अलग, that may be वो आ सकता है. So please revise and I will be back with the next topic. Thank you.